originated from was to prevent fires in buildings from spreading. And the network engineers looked at this and they were very amused and used the same principle in a network to prevent attacks from different networks, basically.
All right. Thank you for sharing. So today we want to look at the introduction to firewalls. And like I said, during data communication, could you please mute your microphone so that we have a successful conversation? Is Tend on forum? She could help me be the co-host, or anyone else willing to be the co-host. Anyone, you can just put up your hand, okay? You just kindly help me with the muting. I've granted you the co-host rights. All right. Thank you. So we're saying that during data communication, insecure factors may cause information leakage, incomplete information, unavailable information, etc. Therefore, firewalls are required during network deployment. Why? Because we want to be able to protect ourselves from leaking our information or having incomplete information, or even us being denied access to our information, plus so many other things like information modification, manipulation, or playing around with its integrity. That's why we need our firewalls during our network deployment. So this course introduces the history, features, typical networking modes, application scenarios, and technical specifications of Huawei firewalls. The good thing is that even in our previous courses, we have been talking about firewalls. So this particular course, we want to take off some time and look at some of the specification of Huawei firewalls. So upon completion of this course, you will be able to understand the basic concepts of firewalls, understand firewall security policies, and also have a good command of firewall security policy configurations, right? So we want to be looking at those things today. Are we all on the same page?
Yes, we are. Yes, we are.
Yes.
Yes, we are.
Okay, you can go ahead and help me mute yourselves. So today we want to be looking at those things. Maybe Mara forgot to mention, she's now currently a staff with Huawei, and she was able to get her job not because of her degree, but because of the various certifications she has done. So when the opportunity came up and they wanted people who would fit her role, and they were asking, for us, they're asking us for the people who had certified and who are very active in our classes, and if we could recommend someone. And she was among the people who recommended, and now she's advancing her career. So we are saying that, back to the course, we are saying that upon completion of this course, you'll be able to understand the basic concepts of firewalls, understand firewall security policies, have a good command of firewall security policy configurations. So firewall overview. We looked at firewalls, and I want to understand what are the firewall overviews. You already told me that we use firewalls to help us protect our networks from intruders or from attacks. So originally, a firewall, just like our colleague talked to us, referred to a wall between houses, and it was basically put there to prevent fire from spreading. The firewall technology is very important, or is an important part of security technology, and that's why this course discusses the hardware firewalls. Now, hardware firewalls integrate security technologies to protect private networks. That is the network that combines our computers, and also to do this, they use the dedicated hardware structures with maybe high-speed CPUs, embedded operating systems, and also support various high-speed LAN interfaces. So the hardware firewalls are independent of the operating systems. I understand in the previous chapters, you looked at the firewalls within your operating systems, right? Like the Windows firewall, like the IP tables. This is on Linux. You looked at those different things, but now we are saying that the hardware firewall is independent of the operating systems, and such as HP Unix, HP Unix, such as the Sun OS, and also the AIX. These are some of the different operating systems for firewall, and computers such as the computers they use. One of the popular one is IBM 600 and the common PC. So hardware firewalls are used to solve network security problems in a centralized manner. They are applicable to various scenarios and they provide efficient filtering. Is this packet allowed? Yes, then permit it. Is this packet not allowed? Then deny it access on our network. So we are saying that they are applicable in different scenarios, and in addition to that, they provide security features such as access control, identity authentication, data encryption, the VPN technology, the address translation, the NAT, address translation. Users can configure security policies based on their network environments to prevent unauthorized users and also to protect their networks. So that's why the modern firewall system should not be just an entrance barrier, but firewalls should be the access control points for our networks. Not just a barrier, but the access control points for our network. All data flows entering and leaving the network should definitely pass through our firewall, and that serves as a gateway for incoming and outgoing informations. Therefore, our firewall not only protects the security of our intranet on the internet, could you please mute your microphone, on the internet, but also protects the security of hosts on the intranet, right? So all computers in a security zone configured on a firewall are considered trustworthy, and communications between them are not affected by the firewall. However, communications between networks that are separated from our firewall must follow the policies configured on our network. So this is what we are saying to say, that our firewalls are going to help us create some kind of logical area filter. We have our LAN here, and we are saying all the computers inside our network, these are considered to be trustworthy. And then those that are going to be passing through our firewall here, now these ones are going to pass through our different controls which we have set on our network. Then of course, hiding the intranet structure, that when hackers are trying to access our network, they do not know even our network range. They can't even access to know how many IP addresses or hosts are on our network, because our firewall is somehow protecting us. Also, firewalls help us to give us security assurance, knowing that no one can access or can send or receive information from our network without the permission. And this is one of the importance of our firewalls. Then of course, proactive defense against attacks. Proactive means that it anticipates that if someone is trying to maybe carry out a distributed denial of service attack, this is what I should do. I should definitely lock out that IP address because it has tried to send maybe ARP attacks on my network, so I should be able to lock them out. So can the traffic that does not pass through a firewall be protected? This is some of the questions that we're asking ourselves. So as you can see here, you have our end user who is connected on our intranet. We have our router to help us transverse our intranet, maybe either to the outside world or even to the internet. So with this, we have our firewall in between our intranet and the wider scope of our intranet. So you can see, sorry, this is the internet. This is our intranet, and we have our firewall that is protecting our intranet. So for us to be able to send and receive packets, we have some control rules or policies that are configured on our server, which are going to help us. If the information is not coming from our LAN, please do not accept anyone who is unauthorized to send packets to our network. And this is what we are looking for. So let us try and look at the firewall classifications. Firewalls have been developed for 3 generations, and their classification methods are various. For example, firewalls can be classified into hardware firewalls and software firewalls. Hardware firewalls or software firewalls. And firewalls, either they can also be classified by form, all, spelling of by form, all also if it is stand alone, right? If it is a standalone firewall, and also it can be classified if either it's standalone or a network firewall. Okay, a network firewall. So all by protection object. So we are saying it can be classified either by hardware or software, either if you're classifying it by form, if it is either a standalone or a network firewall. All right. So in general, the most popular classification method is the access control method. And we are going to be looking at it in the next few slides. So network firewalls can protect the entire network in a distributed manners, and there are features such as, you know, centralized policies, security policies. We can also have diversified security policies. We can also have maintenance by either dedicated administrators or admins, or low security risks, or even complicated policies. So that's how we can have our networks. We have these different features. So firewalls are classified into types according to access control methods, because we say this is the general or the more common kind of types of our firewalls. They can be classified either by packet filtering firewalls. We are going to look at them in detail, or proxy firewalls. We're also going to look at them in detail, and also stateful inspection firewalls. We're going to look at them in the next coming few slides. So let us look at firewall classification and classification by packet filtering firewall. We have our packets here, and we're going to send them from our host here, host A, to be able to communicate with our server B here. As you can see, we have our TCP layer, which is going to go to our IP layer, and which is going to go to our data link layer. In the previous chapter, I think the very first chapter, what did we call this kind of flow? What was it? Sending our packet from the application layer, traversing all the different layers of maybe
encapsulation, maybe.
Encapsulation, right?
Encapsulation.
Yes, and what we call this process here? Getting our packet from our data link layer all the way to layer 3, going up to our transport layer. It was called decapsulation, right?
Decapsulation.
Yes, it was called decapsulation. Thank you. So packet filtering checks packet at the network layer and forwards or discards packets based on configured security policies. The basic principle of packet filtering is to configure the ACLs. Who can tell us what ACLs are in full?
Hello.
Access control list.
Yes, our access control lists. And these are going to be used to filter. Thank you. These are going to be used to filter our data packets based on either our quantipo. Who remembers what our quantipo is? What are the elements in our quantipo?
HTTP,
What were
FTP, Telnet, SMP, DNS, TFTP, SNMP.
SSH.
Okay,
SSH.
those are our protocols. Those are our protocols in our Quantipo, but what are the elements that make up our Quantipo? Do you remember them?
Let me.
Source IP address, destination IP address,
Yes.
source port number,
Source
destination port number.
IP address, all destination IP address. Thank you. Source, all destination,
MAC address.
port number. Okay. We had also our protocols, isn't it? The protocols we are going to use, and those are the elements that make up our Quantipo. Yes, remember them. So we are saying our SCLs are configured basing on, the packets, basing on either our source or IP addresses, or our source and destination port numbers, or our IP identifier, that is the protocol, and then the packet transmission direction in the packet. So that packet filtering firewall in simple design is simple in design and easy to implement. We are saying here that if you are using the SCL or the packet filtering firewall, we are saying it is simple in design. It is also easy to implement, and also it is cost effective. It is cost effective, and the disadvantages of packet filtering are as follow. We are already seeing some of them. So as SCL complexity and length increases, the filtering performance decreases, right? We have some kind of, performance bottleneck. And of course, SCL is also static in nature, right? Once you configure a rule and something is outside that rule, it will not be dynamic. It will definitely do what you configured in that rule. Okay, that's why we are saying that static SCL rules cannot meet the dynamic security requirements. And can you still see my screen?
Yes.
Okay.
Yeah.
Right, thank you. Sorry about that. I had power issues. My screen had gone off and on. And also, packet filtering does not check the session status to analyze data, which makes it easy for attackers to escape. For example, if an attacker sets an IP address of their host to an IP address, which is permitted, right? Which is permitted on our network or on our SCL, what do you think will happen? If you configured and you say permit all traffic coming from 168.1.12, and an attacker knows about this and he goes ahead and sets his host computer to that IP address, what do you think will happen?
It will permit.
It will definitely permit. So in this way, packets from the attacker's hosts can easily pass through the packet filter just by him manipulating his IP addresses. So if you are using a multi-channel protocol like the FTP, based on the negotiation of the control channel, the FTP generates a dynamic data channel port, then the data exchange is performed on the channel. So that also makes it hard for our SCL. So we are looking here that if you're going to send your packet, you're going to go ahead and send it through our firewall, right? Our packet is going to come from point A, and you're going to send it through our firewall, and it's intended to go here. So what it does, it's going to check and see. Only packet headers are checked. Is this the IP layer? Is this a source IP, destination IP? Yes. Is this a protocol we are using? Yes. Okay. This one, either we configured deny or we configured permit. So if it is the IP address, please allow. That's why we are saying only packet headers are checked when you're using packet filtering firewall, and unable to associate data packets. Also, it is unable to adapt multi-channel protocols like the FTP or the TCP, which is going to use the different negotiation methods, which is going to send a dynamic packet. And for you to configure the static packet, it will not understand, and definitely you have issues with users accessing the information. And of course, it does not check the application layer data generally. So this is the ACL. Just a moment. Just a moment. Okay. Right. So moving to the next slide, classification by proxy. What comes to your mind when you hear the word proxy? Let me get a blue pen. What comes to your mind when you hear the word proxy? Anyone? Have I lost my connection or people are just quiet?
It is like a server that handles requests on behalf of the user.
It is a server or something.
It requests,
before even we think of it in terms of a computer, it is basically something that handles requests on behalf of someone else, right? Like an agent. And here we're also looking at our proxy firewall, right? Meaning it's going to handle requests on behalf of our internet server. It's like a middleman, yes? This computer wants to send packets to this guy. He will send the packets. This guy will check through these things and either determines whether to go ahead and send them to this guy. And if this guy has permitted, it will go ahead and send the packets. If this guy wants to return the packets, he'll do the same. He will not send them to this guy. He will send them to the firewall, who will process and then also send back to our internet PC. So what happens, this is like an agent or a proxy firewall. This guy, think of this guy like a broker, right? You have some piece of land you want to buy. This guy has some piece of land he wants to buy, and this guy is the landowner. This guy, our internet server is not going to meet this guy, but what he will do, this guy will come to this guy. Hey, do you know where I can buy land? This guy says, yes, I have land. I think I know where to get the land from. He will check his things and his records and sees if there's someone who is permitted or who has allowed him to advertise his land. And in the case he has allowed him, he'll go ahead and tell him, yes, I have a buyer. How much do you think we can charge him for this land? This guy will communicate back and tell him, you know what? Tell him our land goes for 10 million. This guy, on this guy's behalf, he will go ahead and tell the internet PC, you know what? My land or the land we have will go for 10 million. This guy says, no, you know what? I have 5 million. What do I do? This guy goes ahead and says, hey, but the guy has 5 million. What should we do for him? This guy will say, okay, let him do 8. So at the end of the day, this person has not met the landowner, but they are communicating and they're talking through the broker. So a proxy applies to the application layer of the network, and the proxy checks the series directly transmitted between the intranet and also our internet users. So after the request passes the security policy check, and the firewall establishes a connection with the real server on behalf of the internet user, then it forwards the internet user's request and then sends the packet returned by the real server to the internet server. So a proxy firewall can completely control the exchange of network information and session processing, achieving high security. The advantages, though, is that because now it's going to control whatever information, network information is coming, definitely we already see that we have slow processing. Software implementation limits its processing speed. Therefore, the proxy firewall is vulnerable to denial of service attack. Imagine if it's going to be the one processing all the network requests from the internet, and you have your zombies. Who remembers what zombies are? Mic check. Who remembers what zombies are?
They are infected computers with the by the bot.
Okay, they attacked computers by the bot. All computers on the internet which have been attacked and can be manipulated or used to attack so many computers. So someone has zombies. They use these zombies from the internet to all send requests to the firewall, what do you think will happen to your firewall? You
Will be
have
overwhelmed.
thousands. All right, because you have thousands of requests being pushed forward to our server. Definitely, we shall have slow connections or even lead to the denial of service attack. So the
So Sandy, I have a
application
question.
layer. Yes, please.
If the proxy, is there a situation where the proxy can be, manipulated or what's it called? Is there a situation where the proxy can be hacked or is taken over?
Yes, we have just looked at one of the scenario, isn't it? We are saying
Okay.
you have your which is going to handle all your network coming. It's going to process. Yes, we said it's going to process all and control the exchange of information sessions that is coming from the internet to your intranet. And we said, now imagine someone has a group of computers who he has taken over. Usually this is the Internet of Things, right? Maybe in the cloud. He has millions of devices on the network, on the internet. And he configures these devices all to send information details to your network here. And this guy is going to be the one processing all those details. This guy is going to be overwhelmed. At the end of the day, you are going to get the denial of service. Your end users are going to be trying to access things on the network. The real users who is authenticated are going to be trying to access, and in the process, the hacker can take advantage of the situation. I hope I've answered you. So another thing is that the application layer proxy must be developed for each protocol, and the development period is long, and the upgrade is also difficult. That's why we have difficult upgrades, because now when you are coming up with your proxy, you must develop for each protocol. Now this is the proxy, I need to develop for what? HTTPS. I go ahead, I need to develop for what? For TCP. You go ahead and develop for all the protocols. That's why it takes a lot of time, a long period, and also it is difficult in case you want to make modifications and to upgrade. So looking at the next slide here, we have the classification. We have looked at proxy. Now we are going to look at classification of stateful inspection firewall. We have our host on this network of 10.0.0.1, and we have our server on the network of 20.0.0.1. And these guys want to be able to communicate and share information amongst themselves, right? If you read the previous chapter, you must have come across the stateful inspection, but stateful inspection is an extension of packet filtering technology, right? And we are saying it's an extension of packet filtering. It's an extension of packet filtering technologies, and packets are filtered based on the connection status, right? So with each packet treated as an independent unit, and the historical association of packets is considered here. So all data flows from point A to point B based on reliable connections such as TCP-based connections, all right, such as TCP-based connections, and are processed in three phases. One, the client requests, the server responds, and the client then responds that they have acknowledged the connection has been established, and they need to go ahead and have the packets processed. So this indicates that each data packet does not exist independently, but is closely related to the preceding and subsequent packets. Based on the status association, the stateful inspection here of the firewall, that's where we come up with this kind of technology. Just a moment. Sorry about that. I told you I'm somewhere. I'm not in my office, so there was someone who was disrupting me. So like I was telling you before, that a stateful inspection firewalls uses various session tables to trace activated TCP sessions, right? It uses various tables or session tables to trace the activated TCP sessions, and so do UDP, UDP sessions. So the access control list determines the sessions to be established. A data packet is forwarded only when it is associated with a session. The data packet, I repeat here, can only be forwarded when it is associated with a session. And a sudo UDP session here is monitors the status of the UTP connection process. The sudo UTP session is a virtual connection established for the UDP data flow. When the UDP packets are processed, UDP is a connectionless status, remember, right? So that's why we have a sudo session, and for it, it maintains a virtual connection which is established by the data flow when the packets are processed. The stateful inspection intercepts the packets, the data packets at the network layer, which is layer 3, the network layer. It extracts the status information required by the security policies from each application layer and saves the information in each session tables, right? Sets its information in session tables, and after setting the information in this session table, the session table and subsequent connection requests are related to data packets are analyzed to make proper decisions. So, hey, boss, I'm A and I want to communicate to server B. This is my source IP address. This is my destination IP address. This is my sequence number, and I need to send my packet to this. So it will go ahead and will process the TCP. Remember our 3 handshake? What is the first packet in our 3-way handshake?
Sync.
And the next one?
Sync is
and the last one?
Sync plus app.
Okay. So we are saying after all that information is stored in our session policy, and they say this is my table, I know the destination IP address is this. My source IP address is this now. The destination IP address is this for my computer, my host 1, and these are the different details for this session. So if the incorrect status, if the incorrection, like there's no acknowledgement number, that the TCP connection has not been fully established, our stateful inspection firewall will go ahead and discard the packet. It will go ahead and check the security policy check and see if maybe you're permitting protocols from that IP. And if you're not permitting protocols from that IP, and also it will go ahead and discard or allow. And from there, it will go and process the session information, and it will record the session information in the different tables. This helps in a way that there's fast processing of subsequent packets and of course high security. And there's high security when using this kind of processing of our packets. So stateful inspection firewalls have the following advantages. We have already talked about fast processing of subsequent. The key word to note is subsequent. You talk to the people in that room, eh? Oh God. We talked about that there is a fast processing of subsequent packets and outstanding performance of processing subsequent packets when checking data packets based on the access control lists. A stateful inspection firewall records the connection status of our data flows. The subsequent packets in the data flows do not need to be checked based on the ACL. So instead, the firewall just checks the connection status records of the newly received packet according to the session table which we have. After the check is passed, the connection status record is refreshed to avoid repeatedly checking the data packets with the same connection status. The sequence of records in the connection session table can be adjusted as required, which is different from how the SEL, whose records are arranged in a fixed sequence. Therefore, a stateful inspection firewall may perform fast search by using algorithms such as binary tree or the hash algorithm, thereby improving and having our fast processing subsequent packets. And we have also high security. Why? Because the connection status list is dynamically managed. So if someone thought that they're going to cram the IP address which you used in your SEL to be able to attack your system, remember this, now our session data, all our tables are dynamically managed, and after a session is complete, the temporary return packet entry created on the firewall is then closed. And after it is closed, this ensures real-time security of our internal network. And in addition to that, the stateful inspection firewall uses real-time connection status monitoring technology to identify connection status factors such as response in the session table, which enhances our security system. So moving to the next slide, now let us look at the firewall networking modes. In our mode 1, we have 2 modes, one which happens at layer 2, one which happens at layer 2, and one which happens at layer 3. Okay. We have our diagram there, and we want to try and look at our different modes. In mode 1, let me get my pen. In mode 1, this is our mode 1. We're saying in mode 1, a firewall only forwards packet and does not perform routing. That's why this happens at layer 2, because what it does, it just forwards our firewall here. It doesn't do any layer 3 kind of work. All it does is to forward packets basing on our layer 2 protocols and information. The 2 service network, we have the 2 service networks interconnected by the firewall must be on the same network. So if you want to have our trust zone and a trust zone, why? This is our untrust zone because it's connecting to the internet. This is our trust zone because it's behind our firewall. So if we have our firewall here, and we want them to be able to exchange, we need to make sure that the 2 networks here must be, the 2 configurations must be on the same network. Why? Because we are only doing layer 2 packet forwarding, and we are not doing any kind of routing. So in this mode, after making sure that everything is in the same network segment, the upstream and downstream interfaces of the firewall work at layer 2 and do not have an IP address. This networking mode avoids issues caused by topology changes, because now you don't have to change your topology, and I'm going to explain how. Deploy a firewall like a bridge on the network, and there's no need to modify the existing configurations. The firewall filters IP packets and protects users on the intranet. In mode 2, we said it operates at layer 3, because why? There's some kind of routing done by our firewalls, okay? So in layer 2, our firewall is located between an intranet and the internet. Just excuse me. All right, sorry about that. We are saying that here in our mode 2, which operates at layer 3, we are saying that it is located, our firewall is located between the intranet and our internet. We have our firewall in between our internet and our intranet, right? Between our intranet. And the upstream and downstream service internets on the firewall work at layer 3 within here. we work at layer 3 and must be configured with IP addresses with different network segments. This means that the firewall performs routing on the intranet and internet like a router. In this mode, the firewall supports more security features such as the network address translation and the UTM, but the original network topology must be modified. Why must it be modified? If this guy is going to work and do routing, meaning if you're configuring your network here, this interface on our router will be our default gateway. Isn't it? Also here, it will be the default gateway for the people on the internet. That's why now, if before your router here was a default gateway, now because this guy is going to perform routing for this network to be able to send packets through and go to other networks, it will need to transfer through the firewall's interface. And in this case, the topology is going to change, and this guy, you have to configure an IP address of our default gateway so that the networks are able to communicate. That's why we are saying if they are internet users, and they must modify their gateway configurations on the route configurations on the router must be, modified. Okay, they must be modified there. For the design, personnel should consider factors such as network reconstruction and service interruption when selecting a network or a networking bridge. We're now going to look at the principle of firewall forwarding, and we look at packet filtering technology. When receiving a packet, the firewall obtains the header, compares the header with specific rules, and decides to either forward or discard the packets, isn't it? When it will receive a packet on our internet, when this guy from this branch tries to send the packet all the way to our headquarters, what is going to happen? Our firewall is going to obtain our header. It's going to compare the header with the specific rules we have here, which we have configured in our firewall. And then from those rules, it will either decide whether to forward the packet or to discard the packet. So the core technique of packet filtering is the SCL, just like we mentioned in the previous slides. So as a network security protection mechanism, packet filtering mainly controls the forwarding of various traffic on the network. A traditional packet filtering firewall obtains header information in our quintuple. We talked about it already. And then after obtaining that information, it matches the predefined packet filtering rules and forwards or discards the packet according to the matching results. As the packet filtering firewall matches packets with packet filtering rules one by one, checks the packet, the forwarding efficiency is low. Currently today, a firewall usually uses a stateful inspection mechanism to check the first packet, to check each connection. If the first packet passes the check or the matching packet filtering rule, then the firewall creates a session and it will directly forward all the other subsequent, packets according to the sessions available, right? Forward them according to the sessions available. Let me go to the next slides. Okay, to the sessions available. So if you have come back here, if you have your intranet, computer is connected to your intranet, and you have your branch, and you're using the packet filtering technology, you have your firewall here. What you're going to do, you're going to go ahead and configure your access control lists, your roles in your firewall, and you say only permit packets from my branch here, from this network here. So these guys will be able to send packets. They go through the internet and come to your firewall. Is it coming from our branch? Yes. Then go ahead and permit. But similarly, you also must come here on our firewall and you also configure our headquarters to be able to send back packets. Because if you don't allow it, It will, when it receives the packets from the headquarter, it will discard and you won't have a successful communication. So you have configured and permitted traffic from both your headquarter and the branch. So when the packets come through from your headquarter, it reaches the firewall and it will check it. Is this coming from the headquarter? We permit. It will go through. Is it coming from our branch? We permit. Where is it coming now from? If our attacker tries to, access and sends packets, they will be able to be blocked out. Which network is this? I don't know of that network. Then do not just discard the packets. Do not forward them to our headquarter. And similarly also applies if someone is trying to send to a network that is not permitted on your firewall. It will go ahead and discard the packets. This is what you're looking at. So as a network security protection mechanism, packet filtering mainly controls the packet forwarding of various traffic or on the network. And we talked about that already. So let us try and look at the packet, the firewall security policies. And we look at the definition. The basic function of a firewall is to do what? Who can tell me? Basic function of a firewall?
Filter traffic.
It is to? Why is it filtering the traffic?
From
Why is it filtering the?
To protect.
Yes. The basic
is to filter and send the safe packets through a network.
Yes. In a nutshell, it is to protect a network or our network from being attacked by unknown or unauthorized people.
Yeah.
While at the same time permitting legitimate communication between our authorized networks, right? So we configure our security policies to check our data flows or the different packets that are passing through our firewall. And only the data flows that match the security policies are allowed to pass through our firewall. Control allowed to pass through our firewall. So by using the firewall security policies, you can control the access rates of the intranet to the internet and also control the access rates of subnets of different security levels on the intranet. In addition, security policies can control the access to firewall, for example, by restricting some kind of IP addresses that can be used to log into the firewall, either through Telnet and or through the web user interface. And we shall look at how we can log into the firewall using those IP addresses. And by controlling the communication between our NMS. Who remember what NMS is?
Network management system.
Network management
system.
Yes. So all by controlling the communication between our network management system or server and our firewall. This is what we are looking at. So a security policy controls traffic forwarding according to specific rules or specified rules and apply integrated content security detection to traffic. The rules focus on packet forwarding. So the major applications are security policies control network communications through the firewall, and security policies also control access to the firewall. I repeat, our security policies, they control network communications through our firewall, control our network communication through our firewall, and also control or access to our firewall, right? Network communications, and also they control access to our firewall. Because imagine if you had control to the network communications and you don't have control to access to your firewall. It means a hacker can come and access your firewall and they're able to manipulate your rules and they take advantage of the situation, all of the scenario, isn't it? So moving forward to the next slide. Firewall security policy mechanism. We have already looked at what security policies are. Once again, what are the security policies?
There are rules.
There are rules for?
Because for traffic.
Okay, rules for our data flow or for our traffic on our network. So security policies, they help us to define those rules, right? They help us to define the rules and how the rules when we are going to be processing our data flows on our firewall, right? So the firewall processes data flows according to those rules. Therefore, the core functions of security policies are as follows. One, to filter the traffic. Let me write here. Filter our traffic. It is filter our traffic that is going to pass through, and this is also depending on our defined rules. Oh, this is depending on our defined rules and also determine the next operation performed on the filter based on our keywords. That if someone is sending this keyword, you know what, do not permit. If it's this keyword, please do go ahead and permit. So we said that one of the basic or the basic or the core function of our security policy is to filter traffic, isn't it? It is to filter traffic on our network or the traffic that is going to be going through our firewall. In a firewall application, security policies are basic means of network security access on our data flows passing through the firewall, and they determine whether subsequent application data flows are passed. So the firewall analyzes the traffic and retrieves the attributes, including the source security zone, destination security zone, the source IP address, the source region, destination IP address, destination of the users, the service ports, etc., 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 the application and the schedule. If it is early in the morning, we allow for people to access YouTube, isn't it? Or we deny because people are going to be using and we don't want people to consume our bandwidth. If it clocks 5 p.m., allow our users on our network to access the YouTube IP address and they can go ahead and enjoy accordingly. So that's why we are looking at our mechanism. So the first step here, when the communication is being established, we say the incoming data packets. We say that the incoming data packets passes through the firewall. Just excuse me, just briefly. Sorry about that. So we are saying the first step here, we are trying to look at our different, we are trying to look at the security policy mechanism. And the first step, the incoming data passes through our firewall. This is our firewall. The incoming data comes. When it reaches our firewall, of course, our firewall is going to check our different policies, which we said there are rules, either permit subsequent operations from A, or go ahead and deny the subsequent, operations from B. So it will check those policies or what are the default policy operations. So it will go ahead and it will check those, those policies in our network. So the next step, like I've showed you here, it searches for a matching security policy within the policies that you have configured, and the firewall determines whether to either allow the next operation. So the third step, the firewall processes the data packets according to the rules defined in the policy. If you want it to allow, it will go ahead and allow. If you have configured deny, it will go ahead and deny. So functions of security policies Like I said, filter the traffic passing through the firewall according to our policies, which we have configured or which we have defined, and determine the next operation according to the keywords which we have gone ahead and set. So firewall interzone forwarding. If you read through the previous slides, you must have looked at the different firewall zones. But if you did, you can go ahead and look through those zones after the class. Let me check what's on the chat. I may be here and I'm not audible. Oh, okay. All right. So let us try and look at the different firewall interzone forwarding. Before anything else, we know that early packet filtering firewalls match packets one by one with packet filtering rules, isn't it? And firewalls check all received packets to decide whether to allow them to pass through or to deny them. This mechanism, like we said previously, it greatly affects the efficiency or the forwarding efficiency and creates forwarding bottlenecks on the network, because every packet that comes, it cross checks and looks at it one by one. Okay, we have permitted it to go through, please allow. We have denied it not to go through, please deny. Every packet. So there is a lot of bottlenecks on our network, and also the efficiency is a lot slow. So therefore, more and more firewalls use the stateful inspection mechanism for packet filtering. The stateful inspection mechanism, we said it checks the packets based on the data flows. A firewall checks the first packet of our data flow with packet filtering rules and forwards the results as the status of our data flow. Oh, this packet, we have allowed it. So all the subsequent packets of that data flow, the firewall determines whether to forward them or perform content security detection or discard the packets according to the status. So this status is presented as a session entry, and this mechanism improves detection rate, the one we called proactive security, and also forwarding efficiency of our firewall products has become the mainstream packet filtering mechanism. So generally, a firewall checks 5 elements, now quintuple, and we looked at it. And in that quintuple, which is also part of our IP packet. So there's the source IP address. We said it's going to look at, let me just write it here. It's going to look at our source IP address. After looking at our source IP address, what else is it going to look at? It's going to look at source port number and also look at destination port number. After looking at the destination port number, then it also look at the protocol or the different type of protocol which you have used. So by checking our quintuple, this is what we are calling our quintuple. So by checking our quintuple of each packet, the firewall can determine the packets in one data flow. In addition to the quintuple, we can use our firewall and also to check our users' application and schedules of our packets. In a 3-way handshake phase, fields addition to the quintuple in a TCP data packets are calculated and checked if you are establishing maybe a connection to our server. Could someone please mute your microphone? So we are saying after the 3-way handshake succeeds, the firewall is going to match the subsequent packets with a quintuple in the session table to determine whether to allow the packets to pass through. So all the subsequent packets that are going to come, because it has already checked and it has stored the session, it will go ahead and it will allow. We have our client, which is also trying to communicate with our server. Our clients, all the clients which are behind our firewall are in what we are calling our trust zone, and other who are coming outside or our outbound zone, we're having our untrust zone. So we have our firewall. So this queries the table and inter-zone packet filtering rules based on the inter-zones and the direction to which the interface belongs. So no session is matched, then perform the first packet filter. So when it checks this table and there's no session in that table, it will go ahead and it will, process our first packet processing. Policy 0, it says permit, packets from this IP address. And, policy 1 says deny packets from that IP address. So the default, interzone packet filtering rule is deny. If something comes and it is outside any configured thing and it's not, directly talked about it, kindly note that the default interzone packet filtering rule is deny. And we shall look at it when we start configuring our firewalls in our labs. So if a session is matched here, it will go ahead and perform the subsequent packet process. Note the first packet lookup in the session. So it will just look up for only the first packet. If the session is there, it will go and process the subsequent packets. If it is not there, it will go through the entire process of creating that session and also putting it in the table. Okay, so querying and creating sessions. Here, inspection of packets that match, we are saying that inspection of the packets that match a session takes a much shorter time than on the packets that do not match any session, right? After the first packet of a connection is inspected and considered legitimate, a session is created and most subsequent packets are not inspected because we already know these guys are coming from this particular, imagine you're all seated in a bus, let's say your organization bus and you're going somewhere. Usually when you reach a security checkpoint, people will just check this bus and to see if someone says, they'll maybe ask the first person, where are you guys going? Oh, we have come in for this event and we're invited. We are so and so organization. In most times, they'll not go ahead and ask everyone, so tell us, where are you going? If you are all in that bus, they'll just, trust you. They already know they are expecting you in their guest lists. So because of that trust, they'll just let you go through the checkpoint. Okay, so just let you go through that checkpoint. So this is where a stateful inspection firewall outperforms a packet filtering, kind of firewall, inspection firewall in inspection and forwarding efficiency. So query the session table. This is our session table. After querying the session table, you determine, is there the session in the table? Is the session table matched? Yes. If it is matched, perform the security check to make sure that everything is well and good. If it is okay, update the security table to avoid having repeated sessions, update the security table, and then go ahead and forward packets. And if not, if you check your session table and nothing is in your session table, check whether a session can be created. Yes, a session can be created because we have allowed this traffic to flow from our network. Oh, you have allowed it to flow. So go ahead, server map table, create it, create your routing table, get your filtering nodes, perform the network address translation, then create the session and go ahead and forward the packet. Next time you send something from that particular session, it will check that session and see that it is matched, and it will just go ahead and forward the packet accordingly. So stateful inspection mechanism, we are still looking at it. And here we're going to look for, let us first look at TCP. For TCP, remember, for us to establish a TCP connection, what happens? We need how many shakes? We need 3 shakes. Before even you start sending your packets, you need to first establish a connection, right? And for us to establish a connection, we said we need 3 handshakes. So when the stateful inspection mechanism is enabled, a session can be created only when the first packet passes the inspection performed by a firewall, and subsequent packets are forwarded based on the session. So when it comes to TCP, we are saying that if a stateful inspection is enabled and the first packet we have sent, because remember you have our 3-way handshake, we start with a SYN, which is the first packet. A session is created. And if the packet is not a SYN packet and does not match any session, the packet will be definitely disregarded and no session is created. And if a stateful inspection is disabled on our firewall, a session is created along as a packet that does not match any session passed in the inspection. So if we have enabled stateful inspection, it will go ahead if the first packet is a SYN, because we know the first packet we have in our TCP is a SYN packet. Talking to our server asking, boss, I want to go ahead and establish a connection. So it will go ahead and create a session if the first packet is SYN, if the stateful inspection is enabled. If it is not the packet, it will disregard or it will discard the packet. And if it is not enabled, it will just go ahead and create the packet and to create a session, and a session will be created as long as the packet does not match any session passes in our inspections. So for UDP, remember we said UDP is what kind of protocol? For TCP, we said it is. For TCP, we said it is connection
oriented.
Connection oriented. And for UDP, we said it is connectionless protocol. And if a UDP packet does not match any session and passes the inspection, the session is created. And for IMCP, what is IMCP? What did we talk about it?
It sends requests.
It sends requests. Okay.
Transmit error, control, and query messages.
Okay, to check connectivity, to transmit, and also to check error transmission. So if a stateful inspection is enabled, for the ICMP, echo message does not match any session and no IMCP reply is sent in response, the IMCP echo message is disregarded. If a stateful inspection is disabled, an MCP echo message does not match any session and no IMCP reply is sent in response, the IMCP echo message is processed as the first packet. So the session, we have been talking about sessions and creating sessions. Sessions are the basis of stateful inspection. And a session is created on each data flow passing through the firewall. Each data flow passing through the firewall will create a session. So following our quintuple of those 5 things we talked about, used as a key value, a dynamic session table is created to ensure the security of the data flowing or being forwarded between the zone is managed. So our next generation firewalls extend quintuple with 2 more elements. Take note, with 2 more elements. And there's a user and application information is also added onto the data that is stored. So on top of our quintuple, the next generation firewalls go ahead and also capture the user and the application data. So the session table on our next generation firewalls contains 7 elements. We already know that the quintuple contains 5 elements. We can mention them again. I know we keep mentioning them over and over again, but we can mention them again. Source
IP address.
Source IP.
Source port.
Yes.
Destination
Port.
Destination IP.
Source
Destination
port,
IP.
destination IP, protocol.
Destination port.
Destination port.
Then
Destination port. And then protocol. But we have said that the next generation firewalls add on two things. What are those other two things?
User and application.
User and application data.
User and application data to make them 7. Perfect. So if the packet matches the session, like we say, this guy is trying to say, to send that thing is, and the firewall allows the session to pass, then it will go ahead and create a session on our firewall. As it is storing, it will go ahead and update its session, and it will store the information that we have talked about. That you know what? For the client, this is the source IP address. He's communicating from 192.168.1.1.1 port number this, and is sending to server 1.1.1.1 with port number 23. So what am I going to do? This is our source IP address. This is our source port. Kindly also take note of the destination IP address, and we are using port 23. This port belongs to which protocol?
TCP.
TCP. So we are using the TCP protocol. It is user ABCD or ABC, and they have accessed our server through telnet. For our client, we are using, for our server client, the source IP is this 1.1. The port, the source port is 23. They have access through our telnet, and we are using, the destination address is this. This is the port number, but the protocol we are using to communicate is going to be TCP from this user, and we're using the application of telnet. I to go ahead and create that session and stores it in the session table. So querying the session table, this you get an opportunity to do that, but you just use a display brief information about firewall session table. You say display firewall session table, you put that code in your terminal of your firewall. After you do that, it will be able to show you the details. If you want to display the detailed information about the firewall session tables, you say display firewall session table verbose, and then it will go ahead and it will display and give you the detailed information. But basically, the description of the display information firewall session command output, it gives you the current sessions that are in your table that have been created. It will also tell you if you're either using telnet or maybe HTTP. If maybe you had connected via the browser, this guy is using HTTP, or they're using telnet or SSH to connect to our, firewall, and it will go ahead and also give you the instance of the name and the direction that is the source to destination IP address. And then you have your session table information. So the description of the display firewall session table verbose command, like I said, it gives you all the information you need. It has, it has the sessions that are connected, number of sessions, the protocol names. It is using HTTP, whether there's a VPN instance, and the name, whether it's private or private, plus the source and destination, plus the source and destination IP address, the zone, whether it's coming from either the trusted zone or untrusted zone, the time to leave, sessions, left time on the time to leave, the time left and time to leave, and so many other things. The output, the interface output, outbound interface, next hop, IP address, the MAC address, so on and so forth, if you use that detailed command. And we're going to be able to look at those things, and they'll make a lot more sense to you when we are doing our practicals. So moving to the next slide. What is the time? It is just 11. Oh, it is just 11. Okay. So moving to our next slide, we're going to look at the firewall security policies and application. Security policy matching principle. We're looking at the firewall security policies and application, how we can be able to apply it. So in the first packet process, the firewall matches the packet with the security policy. And we said in the subsequent packet process, the firewall does not match the packets with the security policies. We know that. So we are looking at the matching principle. The first packet, the firewall will go ahead and match to see if it meets our security policy. In the subsequent packets, the firewall does not match the packet with the security because it has already established the trust that, you know what, this packet is coming from our trusted zone. So the first packet is matched with our security policy. If our client A wants to communicate with our server and send the first packet, they'll match. Does it match our rules? Yes. Are we going to permit? These are our rules. Rule 0 says permit packets from 192.168 and deny packets from 192.168.100.0. No session is matched, then perform the first packet session. We already looked at this. And if the default policy, like we said, is deny. If you meet a question saying you, what is the default policy? It's permit or what? Keep note, it is deny. And we do not process subsequent packets or do not match them with the security policy as long as the first policy has been matched with our security policy. So we were looking at the matching principle. Now let us try and look at the process. Let us try and look at the process, the matching process. What did we say with the principle? What happens with the principle? Class, am I still audible?
Yes, yes, you are.
Okay.
Yes,
What did we
yeah.
say? What happens with the security matching principle? What is the principle? Anyone to remember? We said if it's the first packet, what do we do?
A session is created.
A session, it checks it against the security policies, right? And then a session is created. And for the subsequent packets?
The firewall does not match the packets and security policies.
Yes, it does not match our packet header with our security policies. All right. So now let us look at the matching process. So when traffic passes through our next generation firewalls, when our packets passes through our next generation firewall, the next generation firewall matches the traffic. Hey, what has happened? Matches the traffic with security policies, as you can see in this illustration. Our firewall is going to analyze the traffic and receives the different attributes. What are some of those attributes? Who can remember?
Sorry, come again.
We're saying that our firewall is going to analyze the traffic and also receive some of those attributes in our packets, right? And I'm saying, what are some of the attributes of that packet that our firewall is interested in?
Source IP address,
The source IP, the destination IP, source port, yeah. Deep, the protocol, and then user and application data.
Yes, so it will look at all those things. It will look at, it will also go ahead and looks at the zone. Where is it coming from? Where is the destination zone? Am I allowed to communicate with that zone? What is the source IP address? Which region am I allowed to communicate to that region, and so forth? The port, the destination port, what is the protocol, the application, and also we talked about the user and the application data, including also what service am I using? Am I permitted to use that service on my network? Isn't it? And of course, the schedule. Am I allowed at this time, or I'm allowed later on, or maybe next week, or maybe over the weekends? So the firewall compares attributes with the conditions defined in our policies. If it is telnet, please do not allow any computer or host to connect to our firewall or our network using the service of, or using the application of telnet, or do not allow IMCP packets to transverse through our network, depending on what you want to achieve as a security engineer. So if all the conditions of our security policies are matched, the traffic matches the security policy. Okay? We are saying if all the conditions, am I allowed to talk to this source zone? Am I allowed to forward from this source zone to that destination zone? Is this, source address or region acceptable? Is this destination address or network acceptable? Is this user allowed to communicate such information on my network? Is he allowed to use this service? Depending on the rules which you configured on your network. And if the condition is met, then we are saying here that our traffic matches with our security policy. And if one or more conditions are not met, let's say the IP address or the destination IP address is not permitted on the network, the firewall will go ahead and match the traffic attributes with the conditions defined in the next policy. It will look through the different policy and see. And if none of the policies is met, then the next generation firewall takes actions defined in the policy. And by default, we said it is what? Let me even not write it. By default, you said it is what?
Deny.
It is deny. So once it doesn't look and the policy does not match with our conditions, it will go ahead and look through the different policies available. And if no condition is met, then it will go ahead and perform exactly what you set in your policy, but the default policy is to deny. And if traffic matches a security policy, then our next generation firewall performs the actions that you defined in your policy all on the traffic, right? So if the action is deny, and then the next generation firewall blocks the traffic, and if the action is permit, then the next generation checks whether the policy references a profile, and if yes, it goes to the next stage, and if no, the traffic is permitted. If profiles are referenced in the policy and action defined in the policies permit, the next generation firewall integrates the checks on the content carried over the traffic, and it checks if that traffic is allowed. So let me ask, if you configured on your system, and you said if a user tries to use, if the user tries to use the application of telnet on my network, the action should be deny. And a user here tries to access the network through our telnet application and sends in the information. It checks, it matches the source destination, it matches the destination zone, the source address or region, destination address, the user, the service, guess it matches TCP, the application is it's telnet, it matches, and the schedule, it matches. What is our firewall going to do?
Permit.
What do you think?
Deny.
Are you sure it's going to permit?
No.
Because we configured in our security policy. And we said
Okay,
if
no.
the traffic coming from our telnet and it matches and we confirm it is telnet application trying to access, the action should be denied. Isn't it?
Yes.
So it means it will deny, right? Are we
Yes.
on the same page? So it does not
Yes.
necessarily mean that whenever the traffic flow meets all the conditions in the policy, that by default it is permit. Are we together?
Yes.
I could set my condition and say, if the destination IP address is .168.10, I know this is a department, or this is my printer, or this is something that a hacker can use, and I put deny, much as the packets are going to meet all the conditions, and yes, it's going to be 168.10, but my policy says if it matches with that, my action should be deny. So it will do what you have defined in your policy. But if you have defined and it, let's say it is not supposed to use a given service, or let's say the protocol, you said you're not allowed to use, let's say telnet, and the user tries to access and they're using telnet, or maybe let's say all the traffic that is allowed to flow from your network is telnet, and the user with a TCP trying to establish connection from your client to your server, trying to establish a connection from the client to the server, what do you think will be done? And it meets this condition, this condition, this condition, this condition, this condition, but it doesn't meet this condition. It will deny, because by default we said it is denying if it does not meet the condition, our security policy. So the integrated check, like we said, when we are inspecting our profiles to check the data or the content of our data, it inspects the content carried over the traffic based on the conditions that we have predefined or defined in our reference profile, and takes an appropriate action based on the check result. If the security profile defines or denies the traffic, of course, our firewall will go ahead and block. If all the profiles permit the traffic, then of course our firewall will go ahead and allow the traffic. So if we meet the condition, permit or deny. Response, either you go ahead and send or you don't send. Yeah. So there are different profiles that you can configure, whether it's an antivirus, intrusion prevention, universal resource locator, filtering, file blocking, data, application control, mail filtering, and so on and so forth. So moving on to the next slide, the application of security policies. How do we apply our security policies? So compared with our conventional security policies, the ones we have, the security policies on our next generation firewalls can distinguish between employees from different departments based on users, making network management more flexible and visualized. If you have your policy 1 and your policy 2, and you want maybe your marketing department, because of the nature of work they do, to be able to access instant messaging on your network and maybe some kind of game, maybe to make them happy, you can go ahead and configure your first security policy 1 and give them any source address. You want any destination address, it could be any. But if the user is coming from the market department, this profile here, go ahead. If they're trying to access maybe the instant messaging or the game, kindly deny the traffic. We don't want them to spend a lot of time on WhatsApping or doing ABCD. And if the traffic, you go ahead and create another policy. If the traffic is coming from any computer, but the user from that computer is belonging to our R&D, I think what could be that? Called registration and distribution. I don't know. Department. and they are using the protocol, they're accessing through a web browser, HTTP, kindly permit their traffic to come onto our network. So we are saying here that we can use our next generation firewalls to distinguish between our employees. If the department is, let's say, HR, or the department is from, let's say, management, allow those guys to access maybe HTML. Maybe if the department is IT, allow these guys to use other, protocols, or maybe allow them also to use TCP, depending on what you want to achieve, and then you go ahead and you roll out. So it also helps you to distinguish between applications such as, instant web instant messaging, different games using the same protocol such as HTTP, achieving redefined network management. It also helps you to inspect the content. It checks the security and blocks viruses and hacker intrusions for better protection networks. So you have your intranet, you have different departments, the marketing, that one, and they're all sending traffic. As you have seen, we have already configured our different policies on the network. So configuring a security zone on the web user interface, we shall go ahead and look at these things practically. I don't feel like it's making sense for me to just say now, you know what, go click on network zone. We are going to look at them, I think, in the coming few days. I think 1 or 2. We shall be able to look at them and see how best we can configure. But this is how you configure it. There are 4 default security zones. Just kindly take note of that. There are 4 default security zones. And if more security zones are needed, you can create a security zone and define its security level. Configuring a security policy on the web user interface. Security policy includes matching conditions. These conditions, or the different attributes you have already seen, if they match these attributes, either you choose the action whether to permit or to deny. Okay, and the content security profile, this is optional. You look for the profile. Is it coming from antivirus, intrusion prevention, or filtering, file blocking, data filtering? You create a profile. And we shall be looking at that. So basically, those are some of the conditions, but we'll look at how we can configure them on the system. And also we'll look at configuring addresses and address groups on the web user interface, and how we can be able to simulate this firewall of Huawei so that we can play around with the different things. And if time allows, we shall also look at IP tables for those who have Linux, and we see how we can also do the same with on Linux, or the different firewalls that are provided for by Linux. So an address group is a set of address objects. You already know that. And an address object contains 1 or more IPv version 4 or IP address version 6 or MAC addresses. It's like a basic component and can be referenced by different policies, such as the security policy or the network address policies. We shall look at those things practically. So a region is set of a public IP address in certain criteria. This is configuring regions and groups. If you have your public IP address and you know all your clients communicate and receive packets from that public IP address, then a region contains multiple regions or region groups. A region groups can be configured and referenced, and we shall see how we can add different regions. So configuring service and service groups, we'll also look at the different service, but basically a service is a type of application protocol determined by the protocol type, yeah? Is a type of application protocol determined by a protocol type and port number. A service group is a collection of services and service groups. Predefined service is a service that has been preset in the system by default and can be selected directly. A user-defined service, kindly take note of those 2 differences. A service defined by specifying certain information, including a protocol types such as TCP, UDP, and ICMP, and their relevant port numbers. So to do this, like you see in the object, we shall see manually, but you just select the object under the object module and then select services here. After selecting services, you go ahead on the service list, and then you say add. Give your details, add the parameters you need, and after when you're done, go ahead and select OK. So let us look at configuring applications and groups on the web user interface. Also, you can configure applications are computer programs used for special purposes or performing a special task. An application group is a collection of applications. I think these things are a bit straightforward. And we shall look at how you can add them. And configuring a schedule, we'll also look at how you can configure a schedule and play around with that different schedule. Configuring a security policy, you can reference the existing objects in a security policy and how we can be able to add the policy in our system. So just to go back, configuring a security policy, we'll look at the procedure when we get there. Some of these things are really straightforward. Choose policy, go to security policy, and then click on add, enter the name and description, define the matching conditions. We shall do it. Define the matching condition, the addresses if you want. If this guy is from this guy, if you have multiple, select on multiple. We shall go through that physically. It will make a lot of more sense and we shall not waste a lot of time. Then configure security to reference the content policy, and then after you say, okay. An example of configuring a security policy, you look at your network requirements. So basically, plan security policies. If you have the network segment of, let's say, 192.168.5.0/24, which class is this IP address? For those who did networking?
Class C.
It is class C. Okay, very good. And so it is, if this IP address is permitted, but several IP addresses within the range are denied, in this case, configure two forwarding principles. The first forwarding policy defines the specific IP address, and the second forwarding policy allows the entire network segment. If the configuration subsequent is reversed, the IP address will match the permit policy and the packets pass through the firewall. Okay, so you can also go ahead and plan the groups. We shall look at these things, and we shall have this example and we shall try it out practically. And we shall also look at the policy configuration process. You go to start, after that, you configure your things, and after you save and commit, we shall look at them. Right now, they may not make a lot of sense, but here you determine the security zones, and after determining the security zones, you go ahead and assign the interfaces to the different security zones. Yeah. So after configuring the interfaces, you classify employees by source IP, all by user. So you go ahead and configure users and their authentication. You can classify them either by their source IP address. If you know them, that's not going to be dynamic, all by the user. So after doing that, the user security policies determine the permission of the different user groups that you have created. You can configure the addresses of the group, what, those things. Here, they are not making a lot of sense, and I don't want to go through them. And these are some of the key commands which you can use. Now, you can create the policy. I'm going to go ahead and create a video illustrating how you can create your firewall and import it and configure it. And I'll ask you to come and try out these things, try out these policies after showing you how you can do them. And I think that would be your assignment number 4. And see how we can configure them and how you can be able to access the network. So I'll just go through them. But basically, just look at the slide. What does it want me to do? It wants me to configure security policy to deny access to addresses in group range, IP deny to the internet. Which IP deny? You already have your range of IP addresses here, right? And you have already configured them. Which classes are these IP addresses?
C.
C. How many network borrowed bits?
32.
Okay.
We have 3.
Okay. So let us look at the Aspf and try to understand what it is. So most multimedia application protocols, such as the H323, all the SIP, FTP, net meeting use prescribed ports to initiate a control connection and dynamically select a port for data transmission. Port selection is unpredictable, and an application may use one or more than one port at a time. So packet filtering firewalls can use ACLs to match the applications of a single channel protocol to prevent network attacks. However, ACLs can block only applications using fixed ports, but we already know that multi-channel protocol applications that use random ports bring security risks. So a case in example is here. We have a single channel protocol and uses only one port during communication, like the HTTP port. The WW uses port 80. That is okay. But when it comes to the multi-channel protocol, which uses 2 or more ports for communication, for example, the FTP, it has a passive mode, and the user can use either port 22 or the other mode, which uses port 21, and a random port. So how to only use packet filtering modes to precisely define the ports used by multi-channel protocols. So for protocols that use random ports, pure packet filtering cannot define data flows, because if you have specified port 80, and this guy is going to use a random port of 20102, and you're not going to be able to filter or to keep track of that traffic coming through your firewall. So we are looking at the Aspf overview. So the application specific packet filter as an advanced filtering technology checks the application layer protocol information and monitors the status of the connected application layer. It checks the protocol information, the application layer protocol information, and also monitors the status of the connected application layer. So for all connections of a specific application protocol, our application specific packet filter maintains the status information and dynamically determines whether to permit the data packets to pass through the firewall or to discard the firewall. So it does monitor communication packets, and it dynamically creates or deletes filtering rules based on what it has monitored and what it has filtered on our network. So it maintains information about connections in its own data structure and uses informations to create temporary rules. It also stores information that cannot be stored in our access control lists. A firewall checks each packet in a data flow to ensure that the packet status and packet comply with user-defined rules. The status information of this connection is used to intelligently permit or to deny packets. So when the session is closed, our Aspf session management module deletes the session from its session table and closes it in the session table of the firewall. And for TCP connection, our Aspf can dynamically detect that this is a 3-way handshake, and the handshake for connection termination to ensure that there is no more TCP access. So the packets of incomplete TCP handshake connections are rejected if they're not complete. If you have not established the connection, it automatically rejects that. So the UTP, we know it's all connectionless, and it doesn't require a connection. Whereas our application specific packet filter is a connection-based kind of protection of firewall. So it checks the source IP, destination IP, and a port of UDP packet and determines whether the packet is similar to other UDP packets received within a specific period. If the packet is similar, our Aspf determines that these packets are on the same connection. And if it is, of course, different, it will go ahead and it will deny other subsequent packets. So the ACL-based IP filtering technology is widely used for access control. And this technology is simple, but also it lacks flexibility and it is unable to competently protect complex networks. The example is that if you have a multi-channel protocol using FTP for communication, it is difficult to configure the rules on our firewall. But what the ASPF, it enables the firewall to support the protocols of multiple data connections over one control channel, and it also supports various security policies in very complex application scenarios. It helps us to monitor the ports used by each application connection, and also opens an appropriate path to permit the data in a session and closes this path at the end of the session. This way the firewall can control the access of application using dynamic ports. Using dynamic ports. So that way, we have already seen that the ASPF supports multi-channel protocols. It uses to filter packets at the application layer, right? It uses to filter packets at the application layer. So if this guy tries to communicate, it will check the port number of that application, matching it with the source and destination IP address. So, user one uses this port to set up a data channel with user two. Let me keep track of that. And if more other packets are coming up from this port and from that IP address, then I'll know that I should store this kind of data for my user. So in a multi-channel protocol, the FTP, for example, control channel is separated from the data channel. The data channel is directly or dynamically negotiated by the control packets, and to prevent the data channel from being disconnected by other rules, such as the access control rules, a channel must be temporarily enabled. This is why the server map is applied. FTP establishes a TCP control channel with predefined ports and dynamic negotiation TCP data channel. And for common packet filtering firewall, you cannot obtain the port number of the data channel when configuring security policies. So according to the figure, this figure that you're seeing here, the server map entry is generated during the dynamic detection of our FTP control channel. When a packet passes through the firewall, the ASPF compares the packet with the specified access rules, and if the access rules are permitted, the packet will be checked. Otherwise, the packet is discarded if the access list says deny. So if the packet is used to establish a new connection for data connection, our ASPF will dynamically create a server map entry and return the packets, and the returned packets can pass through the firewall only when a matching server map entry is created. So when processing return packets, the firewall updates the status table, and when a connection is closed or timeout, the corresponding status table is deleted to block unauthorized packets. That's why we are saying that therefore the ASPF technology can accurately protect the network even in complicated application scenarios. Generation of server map. Currently, the firewall generates a server map entries in the following situation. Server map entries generate when the firewall forwards the traffic of multi-channel protocols like the FTP or the RTSP. So depending on what you want. So we are saying that how do we generate our server map? We're saying that server map entries generate when the firewall forwards the traffic from a multi-channel protocols like these protocols here. And after this guy is configured on our server, after that, the data on our, the data connection of our multiple channel is negotiated, and our static server maps entries when the NAT server is mapping configuration. Also, the dynamic server maps entries when our NAT or no PAT is configured, or when there's a triple server map entries generated on the firewall, and this is forwarded. This forwards the traffic of the simple traversal of the UDP through the NAT protocols such as the MSCN or the TFTP protocol. Support of multi-channel protocols by port identification. Port identification is also called port mapping. It is also called port mapping, and it is used by firewalls to identify application layer protocols. And these application layer protocols such as FTP, HTTP, PPTP, MMS, SMPT, and so on and so on. So port mapping is implemented based on access control list, and only packets matching the access control rule are mapped. Okay, so the port identification maps non-standard protocol ports to identified application protocol ports. You have your control channel, it will go ahead and it will map those protocols. So it will ask, what is the application protocol for port 31? It doesn't know, but it knows that you have been using this kind of protocol and you're using FTP. So it will go and match this unknown protocol with the known application protocol, and in this case, which is FTP, which was using access rule, this one. So it will go ahead and it will match the unknown port numbers, and it will map it to the known application protocols. So an access control list is basically a collection of subsequential rules, which rules are used by devices to filter traffic on our network. Where is the network coming from? It's coming from HTTP, or we are going to be using Telnet, or it is going to be using protocols such as TCP or FTP. And in this case, we are using a dynamic or a random number, and we don't know where this random number, it belongs to which protocol. We don't know. But through using our multi-channel protocols, or through using what we are calling port identification or port mapping, we'll be able to map our random port to our known application port, right? So SELs are classified into the following types. I don't know if the next chapter is talking about it, no, but they're basically classified into the following types. Just a moment, are classified into the following. Okay, so we're looking at the SEL and we are saying that it is classified into the following types. We have the basic SEL. When you get time, please kindly go ahead and read about them. But we have the basic SEL, which usually runs from that to 299. Kindly take note of that. So a basic SEL matches traffic only by source IP and schedule. This by source IP plus our schedule. It only matches traffic basing on our source IP address and basing also on our schedule. It applies to simple matching scenarios. We have what we are calling the advanced SEL, and with the advanced SEL, it runs from 3000 to 3999. And with this one, traffic is matched by source IP, and also the destination IP address plus a destination IP address, and plus our schedule, also plus the protocol type, plus our priority, plus our IMCP protocol packet type, and if also our plus also our IMCP packet code. And in most functions, the advanced SELs can be used for accurate traffic matching. What you can take note of that, this is used for accurate traffic matching. Basic SEL is used, we use only the source IP address plus a schedule, but it is used in simple matching scenarios. And then lastly, we have the MAC address-based access control lists. These ones run from 4,000 to 49999. Here, traffic is matched based on our source MAC address plus our destination MAC address, and also our costs, and also our protocol code, the protocol which we are going to be using. So this one basically is most of the time is used at layer 2 or at our data link layer from our OSI model. Still looking at this where we can support multi-channel by port identification. We have also hardware packet filtering. This runs from 9,000 to 9499. And this one, after hardware packet filtering, SEL is delivered to an interface card. And the interface card filters our packets using our hardware, which is faster than common software based on packet filtering. And it also ensures that less security system resources are used. Hardware packet filtering access control rules or access lists can match traffic based on the source IP address, the destination IP address, source MAC address, destination MAC address, and the protocol type. So port mapping applies to only the data within an interzone, and therefore, configuring port mapping, you must configure security zones and internet zone. Please take note of that. We are saying that if you want to be able to configure port mapping, before we configure port mapping, we need to make sure that we have configured our security zone. Are we together? Before we configure,
Don't mute those guys. That's wrong.
Wow.
Well, which arcade is that one?
We are saying that before we configure port mapping, we need to first configure our security zones and also the interzone or the internet zone, right? Why? Because port mapping only applies to the data within our interzone. And therefore, when configuring our port mapping, we need to first specify, or we need to first configure our security zones, right? And our interzone. All right. So moving to the next slide, let me see what we have here. Okay. Fragment catch, fragment catch. So a fragment catch is a function used to catch fragments that arrive before the first fragment in the flow. This function prevents the firewall from disregarding fragments, right? Fragments at which layer of our OSI model? So when a network device transmits a packet and we meet the maximum transfer unit, the MTU, and it is configured on our device, and this is shorter than the length of our packet, the packet fragment before transmission. In an ideal sense, this packet will be disregarded because our different packets have different fragments, and we have our length of our packet and how long our packet can be. All right. So persistent connection, why are persistent connections required? We have what they're calling the aging mechanism of firewall session table and problems caused by session aging mechanism to special devices. If the interval of 2 consecutive packets of the TCP section reaching the firewall is longer than the aging time of the session, the firewall deletes the session information from the session. In this case, after a subsequent packet reaches the firewall discards the packet because it will check through our session table, and this session will not be there because after all, we have already deleted our session from the system. Okay, so as a result, the connection is interrupted. Some services require persistent sessions. To solve this problem, the firewall supports the configuration of persistent connections in the interzone. So by referring or referencing the access control lists to define data flow rules, you can also set a long aging time for the session of the packets that match the access control rules to ensure that normal use of the sessions. The default aging time of a persistent connection is usually 168 hours. And also, the firewall supports the persistent connection function only to TCP packets. Okay? So when a stateful inspection is disabled, the firewall also creates session entries for non-packet or for non-fast packets. In this case, you do not need to enable persistent connections. Why? We are saying that if we have not configured or enabled stateful, right, we do not need to enable our aging mechanism. Why is that so? Remember what we said with the stateful connection? Or what we said with our stateful firewalls? Or stateful inspection? Remember what we said? That it will only inspect the first packet. It will cross-check with our session tables to see if it meets with our security policies and rules. And if that's the case, it will permit the packet. And also, when you send other packets, which are not the first packets, it will not check them. It will just forward the subsequent packets, isn't it? Do you remember that? It will just forward the subsequent packets. It will not check them if you have enabled the stateful inspection. But now here's a scenario. We are saying that if we have bad network and we have not configured persistent connection, let's say you are trying to establish TCP connection. Your client here wants to access the database, or they want to write and post a transaction to your database. They go ahead and establish the TCP connection, which goes ahead and it is successful. And then they go ahead and start sending the first packet. They send it and it reaches very well because everything matches our security rules. But now, because of network interruptions, because of poor network, this guy takes long to send other packets as we are waiting for our ISP to correct his internet. By the time this guy remembers now to send the packet, this guy, because we did not configure the aging mechanism on the firewall, he will go ahead, because we said after some time, he will delete those other sessions which are dormant from the table. He will go ahead and delete the sessions. So when this guy sends the packet, and it's not the first packet, it's another packet of the data which was remaining to be transmitted to this guy. What do you think will happen to this packet? Where its details are not part in our session because the session was already deleted. What do you think will happen to that packet?
To be destroyed.
It will be discarded, isn't it? Yes. But now we are saying to overcome this problem, that's why we are coming up with a persistent connection configuration, which we are saying only is supported all functions on our TCP connections, which are secure connections, we all agree, not so. Connection oriented.
Yes.
There are secure connections. And we are saying that we can go ahead and configure and set our aging mechanism. And we say by the default, it is 160 hours. As long as we have configured and established our connection, our packets are complying or are matching with our security security policies, kindly do allow all other subsequent packets which are going to come from this particular session. As long as it was there in our session table, kindly do allow them. Even if this guy had network interruptions for about 2 hours, and when we resume, you are able to complete your transaction. When this packet comes through our firewall, it will check the session is there, it's a subsequent packet. Go ahead and forward the packet to the intended destination. So we are saying this was a problem which was caused. So in case we have already enabled, we have not enabled our stateful inspection. What happens when the firewall receives a packet? The first packet? Please talk to me. What will happen if it receives a packet? If this guy is not, and we are using packet filtering,
a session will be created.
A session will be created. Very well. We shall create a session. What also will happen if we send another packet? I saw the first packet.
I think it will do the same. It will query and create a session for that packet.
Yes, it will go ahead, cross-check, looks through the packet information, cross-check with the security policy, and create a session and sends it, right? But we are saying if this guy is not created, if this guy is not enabled in the system, that means that we don't have to enable our aging mechanism. Because regardless of if this was, whether go ahead and process the packet, looks through our policies, looks through our sessions, and either forward the packet or discard the packet depending on our defined rules, isn't it? So that's why we are saying that when stateful inspection is disabled, the firewall also creates session entries for non-fast packets. In this case, that's why we do not need to enable the persistent connection function. So set the aging time for a persistent connection, and firewall long link aging time will be in our system, and also then go ahead and enable persistent connection. And firewall interzone, you set the name, and we shall look at those specifics when we are getting there, right? So if no data is transmitted within the session aging time, remember our session is disconnected automatically, just like we said earlier on. So we have our quiz here. In which of the following situations will the server map entries to be generated? We talked about this, you remember? We talked about when NAT server mapping is enabled, remember? We also talked about when ASP is enabled. We did not talk about a persistent. The answer is ABCD. We did not talk about the persistent connection when it is configured. The things we talked about here in our section, here we said when server maps entries generated when the firewall forwards the traffic over multi-channel protocol, such as FTP, RTSP, and then the ASP is configured. After the ASP is configured. We also talked about static server map entries generated when the NAT server mapping is configured. We also talked about when dynamic server map entries generated when the NAT no PTA is configured. Then also when the firewall forwards traffic over simple transversal over UDP through the NAT, protocols such as the MSN and TFTP, and after the ASPF is configured. So according to our question here, we see that we talked about this. We talked about NAT, server mapping is configured, and we also talked about ASPF is configured, but we not talk about the non-persistent connection when the non-persistent connection is configured. Then 2, a firewall has 4 default zones and security levels, and the security levels of the zones cannot be changed. True or false? It is?
True. True.
It is true. It is true because we said it has 4 default zones, yes. And these 4 default zones have default numbers. And these default numbers cannot be changed. Kindly take note of that. So, what is the time? Okay. We are done with our first PowerPoint slide. And it is almost midday, but let me use this remaining time to show us what we need.
So we have failed to